While riding his bike to a pond, Stephen's distance in miles is modeled by t cubed minus 3t squared plus 3t. If the lake is 9 miles away and t is measured in hours, A, what was Stephen's maximum velocity during the trip and when did it occur? So there are two things you need to keep in mind here. To have a maximum, you should check when the derivative changes from positive to negative. But if there are endpoints, you also need to check endpoints. So first thing I'm going to do is check the open interval. So I'm going to figure out when velocity has a maximum. So I need to find velocity. Velocity will have a maximum when its derivative changes from positive to negative. So then I find the derivative of velocity, which is acceleration. If you think about a line 6t minus 6, that's a y-intercept of negative 6 and then has a positive slope. This graph doesn't change from positive to negative. It changes from negative to positive. So that tells me the velocity decreases and then the velocity increases. So that being the case, we're going to have to definitely check our endpoints because there is no maximum velocity over the open interval. So what are the endpoints? Well, the second endpoint will be when the distance is equal to 9 because that's when he reaches the pond. So I'm going to go ahead and solve the distance equation set equal to 9 so I can figure out when he gets to the lake or gets to the pond. So subtract 9 from both sides. Yes, this is factorable. It's factorable by grouping. You can factor out a t minus 3 from the first two, factor out a t minus 3 from the second two, and then you're left with t squared plus 3 times t minus 3, which gives you t equals plus or minus I root 3, so that's not an answer, and t equals 3. So t equals 3, I don't know why I said when the race ends, it's just when he gets to the lake. But t equals 3 is when he gets there. So my first endpoint is at 0, my second endpoint is at 3. If you plug 0 into the velocity equation, you have 3. If you plug 3 into the velocity equation, you get 12. So his velocity was at a maximum when time t equals 3, and the actual maximum velocity was 12 miles per hour. So when you check your endpoints, make sure you plug them into the velocity equation because we're testing for a maximum velocity. Don't plug it into the distance equation. B, did Stephen ever stop during the trip? So if he stopped, that's when the velocity is equal to 0. So let's see if the velocity is ever equal to 0. I can factor out a 3 here. And then you can factor this further to be t minus 1 squared. So yes, he did stop at t equals 1 because that's when the velocity is equal to 0. So if you had gotten non-real answers here, then you would say, no, he never stopped because you don't get a real value for time. But because you get a positive value for time, then yes, that tells me he stopped somewhere between 0 and 3 seconds, which specifically is at t equals 1. C, what was Stephen's average velocity? So the way you can figure out average velocity is that's just going to be the average rate of change, which is slope of position. So that's going to be the position at t equals 3, the position, because that's when he gets to the lake, minus his initial position over 3 minus 0. So remember, average velocity is the average rate of change, and that's the slope of the position function. So that gives me 9 minus 0 over 3, the position at 3 seconds and the position at 0 seconds. And that's 3 miles per hour is his average velocity.